Nowadays, weight training has become a very popular modern exercise. However, one problem with muscle building is that incorrect postures or lifting excessive weights might lead to injuries. These include muscle compensation, which means one is overusing other muscles that are not subject to training. Yet, it is very difficult to spot muscle compensations with bare eyes, especially without the professional coaches. Thus, these types of malcompliance often go unnoticed. To this end, we want to utilize SEMG signals to evaluate muscle performance and warn users of muscle compensation. In our project, we focus on the compensation of the upper trapezius muscles during bicep dumbbell lifting.
The first step to using the app is the calibration process, which users are requested to relax for 10 seconds. The SEMG signals of a relaxed shoulder will be utilized in the normalization later on. On the main page, the graph displays the SEMG signals of the bicep muscles. The extent of muscle compensation in our app is represented by three figures. The yellow joy represents no compensation, the blue sadness represents some compensation, and the red anger represents serious muscle compensation. When this happens, a Click Me button will appear, which will guide the user to several instructions of how to relieve muscle compensation. This design is due to the fact that muscle compensation is seen as a skill rather than binary classification. For now, I am lifting a 4 kg weight, and no compensation appears. Next, I will try lifting the 4 kg with incorrect posture, that is, stretching my elbows further away from my body. With this incorrect posture, compensation quickly appears. Now, let me try the 10 kg weights. The app apparently tells me that significant muscle compensation has occurred, which means I am seriously overusing my upper trapezius muscles. With the warning from the app, I know that I should relax for a bit or reduce to some lighter weights to avoid injuries.
In future work, there are two things waiting to be improved. First is the way to classify the muscle compensation conditions. Recently, we normalized the EMG signal from trapezius muscles by dividing them by the mean EMG amplitude during rest. And then we set a threshold of 5 and 10 to distinguish the conditions of no compensation, slight compensation, and serious compensation. However, this is a rough classification because there are differences among the participants. Therefore, we should develop a method to perform user-based compensation detection rather than using an exact value of threshold. Second is to enable real-time user feedback. In a present stage, we extract the signals first and then process the data offline. In the future, we should carry out onboard data analysis. We can attain the goal by upgrade the controller from Arduino Uno to Raspberry Pi or processors with higher computation capability.